In lecture 14, we will discuss the K-map simplification for a three variable. Actually, lecture 13 to 16, mainly we will focus the K-map simplification or Karnaugh map simplification. In lecture 13, we already discussed how to solve a two variable K-map, or how Boolean expression can be simplified using K-map. And now we'll discuss in lecture 14, mainly the three variable Boolean expression. Okay. And this section is we are already discussing the SOP simplification, and later we will discuss POS. And if you consider a three variable K-map, just like in the case of two variable, if you consider two variable, then 2 square you will get 4 different combination. Now this n is equal to 3. 3 variable means 2 raised to 3. That is actually 8 different combinations, or 8 different possibilities are there, or we can say 8 different min terms will be there in SOP expression. So we need 8 different squares in the K map or Karnaugh map. In another important point, so you can consider one particular K map for a three variable. So you need 8 different cells and 8 different min terms will be there. But one important point regarding this three variable, if you consider x, y, z variable, in this particular format, there are 2 rows and 4 columns. And one variable is arranged in row wise, that is x. So you can write 0 and 1 here, that is x bar and x. But in column wise, there are 2 variables, so we'll get 4 different combination. But when you write the combination, that 4 different combination in the binary order, it is 0 0 0 1 1 0 1 1. Actually 0 1 2 3. But when you write in the K map, the sequence is different. That is 0 0 0 1 and 1 0 you will write at the end, and then 1 1. Okay, that is the format we used in K map, because in K map we are not using the binary sequence. We are not writing in binary sequence, we are using in a gray code sequence. So there is only one bit change in the adjacent cell. So if you consider the first two columns 0 0 and 0 1, there is only one bit change. This 0 is changed to 1. Now if you consider the second and third column, here you can see that only one bit change, that 0 is changing to 1, that 1 is same. And if you consider the last 3 and 4 columns, you can see there is only one bit change. Okay, that's why this gray code is actually used in the K map. That is a standard format used in K map, not the binary sequence. So when you write the sequence, make sure that you are using the gray code sequence. Don't write in the binary sequence. And the corresponding terms are y bar z bar, and y bar z, y z, then y z bar. So this is very important when you write the K map, more than 2 variable, 3 and 4. You need to use this sequencing, gray code sequence. Now the min terms corresponds to each term. For example, this is actually 0 0 0. This is 0 0 1. Actually, this is 0 1 1. The last one is 0 1 0. And in the lower case, it is 1 0 0. This 1 0 1. And here it is 1 and 1 1 1 1 1. And the last one is 1 1 0. So this is actually M0. This is M1. M2 will be here, M3 here, M4, M5, and M6 and M7. So in this way, you need to write the K map, and this is the final representation. If you write the min terms here, this term will be X bar, Y bar, Z bar. Instead of the 0 0 0, you can write the variable notations. Okay. Now we can consider 3 variable. I'll repeat the process. So here you can see the 3 variable K map simplification. This is one representation, M0, M1, M2, M3, M4, M5, M6, M7. So in another way also you can represent the 3 variable K map. So this is another way. So instead of writing 2 rows, we'll write 4 rows. That actually 4 combinations available in row wise and 2 combination. For example, if you are using ABC variable, you'll write AB here. So you'll write A 0 0 0 1 1 1 1 0. That is A bar B bar, A bar B, A B, and A B bar. Okay. In column wise C, so you can write C bar and C. Okay. So you'll get exactly the same thing, but result after simplification. But when you write the min time, you can see that this is 0, 1, 2, 3. Instead of writing 4 here, we'll use in the last 4, 5, 6, 7. Okay. In this way also I can. So some textbooks follow the second method and some follows the first one. I mostly prefer the first one. So when we discuss the questions, I will use the first format, 2 rows and 4 columns with that. If you're comfortable with the other, you can go for that also. Okay. And now we'll discuss the problem. So here it is given to solve the question, solve the function sigma 2 3 4 5. So it's again an SOP representation. That's why sigma is given. We need a 3 variable k map. Okay, we can try that 3 variable k map. So this is a 3 variable k map. We need to draw that 3 variable k map. So there will be 8 different cells. So x, y, z, and here x can vary 0, 1, y, z can vary 0, 0, 0, 1. Once instead of writing 1, 0 here, we'll write 1, 0 here, 1, 1. Okay. So min terms will be m0, m1, m2, and m3. Here it is m4, m5, m6, and m7. So you can remember this particular sequence. And in terms of variable, if you write x bar, x, and here it is y bar, z bar, this is y bar, z, this is y, z, and this is y, z bar. Now you need to indicate the function magnitude. When x, y, z is equal to 2, you will get a 1, and when it is 3, it's 1, when it is 4, it is 1, when it is 5, it is 1. For all other values, it becomes 0. So now we need to group this. So you can try a group of 8, 4, 2, or 1. If 8 grouping is possible, go for that. Otherwise 4, try for 4. If not possible, go for a 2. So now in this particular case, there is only option to group these two ones. So we can write the equivalent min term for this particular group. If the row wise, if you look, the common term is the 0. So 0 corresponds to x bar. Now in column wise, if you look at here, you can see that this 1 is common. Okay, this 1 is common for both column 3 and 4. So this 1 is actually corresponds to y. So you can write x bar y. Okay, column wise, if you look at, this is 1 and this is also 1. But z is changing 1 and 0. So we cannot consider z. The common term we will consider. So 1 is common for both this column 3 and 4. So we'll consider y for representing that. And now we can see another 2 ones here. So I can consider another group 1 1. So for this particular group, if you consider row wise, it is x, and column wise, if you consider first and second column, you can see that 0 is common in both column 1 and 2, and this 0 is corresponds to y bar, so x y bar. So I can write the expression, this is x y bar plus x bar y. Okay, and now we can explain another question. So I can conclude this problem. So this is a representation of this particular question. After grouping, you will get x y bar and x y bar. Okay. So x bar y here. Here it is x y bar. Now we'll consider another question. Here the function is given in terms of variables. So it is x bar y bar is z, x bar y is z plus x y bar is z plus x y z. So again it's a function of three variable. So you need to represent x, y, z, and you need to write 0 1 here to represent x bar and x, and here it is 0 0 0 1 1 0 1 1. Okay, so you can write y bar z bar, y bar z, y z, y z bar. Okay, and corresponding minterms m0, m1, m2, and m3, m4, m5, and finally we'll write m6 and m7. The final cell will write 2 and 6. That's the only change you need to note down. And now we need to indicate the values. So for example, it is x bar. X bar is the first row. Y bar is set. Y bar is the second. So here it will be 1. And if you consider second term, it's x bar. Again, row 1 needs to consider y is set. Means third column. So it's 1. And x so means second row. Y bar is set means y bar is set means second row, second column. So here you will put 1. And the last term x y z. So x here, y z in the third. So 1 1. So other cells you will mark it as 0. So you got now we need to group this ones. So you will try for 8 4 2 1. Okay. So 8 ones you cannot, only 4 ones are there. So we'll try for a group of 4. So we can group this 4 ones as a single group. Okay. Now we need to consider the min term corresponds to this particular group. In row wise, if you consider one is x bar, another one is x. So there is no common term. One is 0, another is 1 1. So but in column wise, if you consider here it is 0 1, here it is 1 1. If you consider this one is common for both column 2 and 3. So this one is actually corresponds to z. So I can write the entire expression is equal to z. So the lengthy expression now reduced to a single variable. Without any gate, I can implement this particular function. Okay. Now we'll discuss another question. Now in this particular question, again 3 variable x, y, z is given. Okay, and so x, y, z we will indicate. Here it is 0, here it is 1. X bar x, it's 0 0 0 1 1 0 1 1. So y bar z bar, y bar z, y z, y z bar. Now we need to fill this by using min terms. So instead of writing m, I will write simply put 1 0 1 2 3 4 5 6 7. So this is actually indicating the min time corresponds to this. Either you can look in the previous example we tried like this method x bar. So first row and y bar z bar means first column. So we can put here 1. So instead of looking like this variable, I can also use another method. So you can write the binary sequence corresponds to each variable. So here it is 0 0 0. This is corresponds to 0 0 1. This is 0 1 0. This is 1 0 0 1 1 0. This is 1 1 1. So and this 0 0 is corresponds to min term 0, and this is 1. This is actually 2. This is 4. Binary 4. This is 6, and this is 7. So your function will be like this: sigma 0, 1, 2, 4, 6, 7. So instead of checking for this variables, I can directly mark these values. So 0, I need to put 1. Here it is 1. And for min term 2, it's 1. 4, it's 1. Min term 6, it's 1. For min term 7, it's 1. Okay. Now we need to group this values. Okay. 0, 1, 2, I think it's correct. 0, 1, it's 0, 1, 0, it's 2, it's 4, it's actually 6, and finally 7. So 0, 1, 2, 3, 4, 5, 6, 7. So other portions I will put it as a 0. Okay, two values I will put it as a 0. Now we need to group this. So in order to group this particular sequence, I will check is there any possibility of group say 8. It's not possible, there is only 6 ones. So now next I can write for group of 4. So if you try group 4, see there is one possibility to group this k map when there is ones at the edges. So I can consider this two ones and the last two ones. So in this way I can group a 4. So if you consider this group, we are considering 1, 2 row, there is no common term. But if you consider the first and fourth column, the common term, here it is 0, 0, here it is 1, 0. So we can see that 0 is common in both first and fourth column. So I can write Z bar for representing this particular group. And another grouping I need to check, here it is X bar. If you check X bar, it is sorry, if you consider this 0 and 1 group, if you consider min term 0 and 1 group, here it is X bar. Okay, X bar is here. And if you consider the column wise, its common term is 0. So you can write X bar, Y bar. Now, if you consider the min term 6 and 7, you can consider another group for representing this term. Row wise it is X, column wise 1 is common, so you can write XY. So the final expression will be like this: X bar, Y bar, X, Y plus Z bar. Okay, so now we'll discuss another question. Here again 3 variables A, B, C, and the function is given in min terms or SOP form 0, 1, 3, 6. So the variables A, B, C, here you can write 0 and 1. So it is A bar and A. Here it is 0, 0, 0, 1, 1, 0, 1, 1. It is B bar, C bar, B bar, C, B, C, B, C bar. Now in terms of min terms 0, 1, 2, 3, 4, 5, 6, and 7. Now we need to indicate 0 as 1 and 1. In 3 it's 1, 6 it's 1. Okay. Now we need to group this. And if you group this, you can consider two ones here. Okay. So the term corresponds to this group as A bar. Okay, in row wise A bar is common. In column wise B bar is common. Okay, and you can consider group 1, 3, min term 1 and 3. And if you group min terms 1 and 3, again you can write A bar common in row wise. Column wise you can see that C. And finally there is a 1. So there is no option to group this one. So I'll write the single term. So in row wise it is A, in column wise it is B, C bar. So the final expression will be like this: A bar, B bar plus A bar, C plus A, B, C bar. Okay, so this is the final expression for this particular question. Now we need to consider three variable A, B, C. So I'll write A here, B, C here. So here it is 0 and 1, A bar and A. Here it is 0, 0, 0, 1, 1, 0, sorry, it's 1, 1, and finally 1, 0. So B bar, C bar, B bar, C, B, C, B, C bar. So in terms of min, 0, 1, 2, and 3, 4, 5, 6, and finally 7. So we need to indicate 0 as 1, 1, 3, then 5, and 7. So total 5 values. So here it is 5 values. Now we need to group this. So if you consider this group, there is 4 ones. In order to represent this 4 ones, in row wise there is no common term. In column wise, if we consider, there is a term C. And now we can group this min terms 0 and 1. So in row wise it is A bar. In column wise, B bar is common. So you can write A bar, B bar. So this is a final simplified expression, A bar, B bar plus C. So other term I will put it as 0. Okay. Now we'll consider another question. This is a three variable A, B, C, 0 and 1. Here it is A bar, it's A, it's 0, 0, 0, 1, 1, 0, 1, 1. It's B bar, C bar, B bar, C, B, C, B, C bar. Okay, and 0, 1, 2, 3, 4, 5, 6, and 7. And here I can see that 1, sorry, I made a mistake. Here it is 0, there is no 0, this 1. And let's check in the previous case. Okay, there is 0 and 1, 3, 5, 7. Okay. Now it is 1 we need to indicate, 3 we need to indicate, 6 we need to indicate, 7 we need to indicate. The other terms will be 0. So, okay, 4 terms. Now you need to group this. We group, this is one group. So here in row wise, if you write, it is A bar. In column wise, if you consider, it is C. Now this is another group. If you consider this group, A will be there, and column wise B. Okay, B is common term. And in this particular question, you don't want to consider again these two ones. Okay, there are also two ones. There is a possibility to group this one, but this term we will call as a redundant term. We don't want to consider this particular group because already we grouped this one, and we will not consider this dotted group. So we can write A bar C plus AB. Okay. Now finally I will discuss one more question. So this question is actually solved in the again it's a three variable, but we will use the other format. Okay, 4 rows and 2 column method. Here you can see that it's given A, B bar, C, A bar, B, C, and the standard SOP form. Okay, I'll write the equivalent binary value 0. Okay, sorry, it's 1, 0, 1. It's 0, 1, 1, 0, 0, 1, 0, 0, 0, 1, 0, 0. Means it corresponds to 5. It's 3. It's 1. It's 0. It's 4. So if you take this particular K map, okay, the time will be like this: M0, M1, okay, 2, 3, and finally write 4, 5, and 6, 7. So from this example, 5 we need to consider. So 5 is indicated here. Then 3 we need to consider. So 3 is already indicated. 1 we need to consider. This is 1. And 0 we need to consider 0. And finally 4. Okay. And if you consider this particular group, AB written in row wise, so 4 combinations will be there. So it is A bar, B bar. It's A bar, B, then AB, and A, B bar. And in column wise, you C is there, so we can write C bar and C. Now we can group the first row M0, M1, M4 and M5 we can group. So if you consider this group, in column wise there is no common term, but row wise if you consider the first row and the last row, 0 is common for both first and fourth row. So you can write B bar here. Okay, that's why it's B bar. Now you can group M1 and M3, and for M1 and M3 if you consider row wise, uh, 0 is common. So in order to represent 0 we need to write A bar here, so that is A bar. In column wise C is common, so A bar C. So the final expression will be A bar C. The same question I can approach in other method also. You will get exactly the same result in both method, both representations. So here it is A, B, C. Here it is 0 and 1, that is A bar and A. Here it is 0, 0, 0, 1, 1, 0, 1, 1. B bar, C bar, B bar, C, B, C, B, C bar. So 0, 1, 2, 3, 4, 5, 6, 7. So you need to indicate 5 here, okay, and 3 here, and 1 and 0, finally 4. Okay, sorry, 0 I need to indicate 1. Okay, 0 I need to indicate 1. So you will get a group of 4 from this. So this is a group of 4. You consider this group. Here you can see that in first case it is 0, 0 is common, that is B bar. So in order to represent this, we can write B bar. And if we consider the other group, group 1 and 3, if we consider A bar is common, A bar is common, then in column wise, you can see that C is common. So A bar C. So we can see that A bar C is here, B bar C. So A bar C plus B bar. So both method will give you the same result. Okay.